Alright, lesson 12.1 is quadratic graphs and their properties. A quadratic function is a function that can be written in the form y is equal to ax squared plus bx plus c, where a is not equal to 0. Y is equal to ax squared plus bx plus c is the standard form of a quadratic function. For example, these are all examples of quadratic functions. Y is equal to 3x squared, y is equal to x squared plus 9, y is equal to x squared minus x minus 2. The simplest quadratic function is f of x is equal to x squared or y is equal to x squared. That's the same. F of x represents y, so they mean the same thing. And this is the quadratic parent function. Now in this lesson you're going to need to pause and make sure you get these notes down before you move on. Alright, the graph of a quadratic function is a U-shaped curve called a parabola. So this curve here, we refer to that as a parabola. And the fold or the line that divides the parabola into two matching halves is called the axis of symmetry. So it's kind of hard to see here, but there's a navy dotted line that goes through the center of that, and that's your axis of symmetry. Okay, it splits that in half, so like you could fold your paper over that axis of symmetry and both sides would be exactly the same. The highest or the lowest point of a parabola is its vertex, which is on the axis of symmetry. Alright, if a is greater than 0, which means that a is positive, in y equals ax squared plus bx plus c, then the parabola opens upward and the vertex is the minimum point or the lowest point of the parabola. So what that means is if a is positive, then you know your graph is going to look like this. It's going to open up, and this lowest point here, your vertex is a minimum. If a is less than 0, in y equals ax squared plus bx plus c, then the parabola opens downward and the vertex is a maximum point or the highest point. So if your a is negative, you know your parabola is going to look like this, and you're going to have this is going to be your maximum, and this was your minimum. It's like at the bottom is a minimum, at the top is a maximum. Alright, so these are what those parabolas might look like. Here it's a minimum. So here we know that a was negative. A was positive and it opened upward. Here a is negative and it opens downward, so you have a maximum. And this is what that might look like on a coordinate grid. Alright, so here you have a minimum at the bottom. Here you have a maximum at the top. Here I know that a is negative because it opens down. Here I know that a is positive because it opens up. Alright, once again, you're going to need to pause and make sure you take time to write these notes down. Alright, next we're going to talk about graphing a quadratic function. Graphing y is equal to ax squared. Make a table of values and graph y is equal to 1/3 x squared. Alright. Now, the numbers that you use in your table for x are kind of going to be up to you. Here, I'm going to use multiples of 3 because I know when I do that, that's going to help me get rid of this fraction with a 3 on the bottom. So if I plug 1/3 and I plug 0 in for x, then I know 0 times 0 is 0, times 1/3 is 0, so my ordered pair is 0, 0. Alright, and if I do 1/3 times 3 squared, 3 squared is 9, so that gives me 1/3 of 9. 9 divided by 3 is 3, so I'm going to have 3, so this is going to be 3, 3. And then 1/3 of 6 squared. 6 times 6 is 36. 1/3. So 1/3 times 36. 36 divided by 3 is 12. So I'm going to have 6, 12. Alright, so now I have 3 points. And I'm going to need to graph those. All right, so I'm going to graph those 3 points on the coordinate grid. All right, so my first point is 0, 0. My next point is 3, 3, so that means I go right 3 and up 3. And my next point is 6, 12, so I go right 6 and up 3, 4, 5, 6, 7, 8, 9, 12. Okay, so now I have 3 points. The next step is to reflect those points from the table across the axis of symmetry. Well, here, my vertex is at 0, 0, so I know my axis of symmetry here is x is equal to 0. So here's my axis of symmetry. So I'm going to reflect these points. This one's 3 points to the right, so a reflection would be 3 points to the left. This one is 6 points to the right, so a reflection would be 6 points to the left. All right. Then I connect those in a U-shaped curve known as a parabola. All right, this equation was y was equal to 1/3 x squared. A was positive, so we knew it would open up, and we knew our vertex would be a minimum. So this is our vertex. And the domain is always my x values. So this is the domain. And the range is always my y values. So here the domain is 0, 3, 6. The range is 0, 3, 12. All right, so those are the ones that I used, but are these the only x values that are involved in this graph? No, my x values start at 0 and they go up. So my domain is my x values. This is the x-axis. If this continues going up, it's going to continue spreading out. So the domain is all real numbers. It's going to continue spreading from left to right. So the domain is your x-axis. And this is going to continue spreading over the whole x-axis. The range is where it touches your y-axis. This is the y-axis. It starts at 0 and it goes up. So the domain, or the range is going to be y is greater than or equal to 0. Okay? So the range is where it covers your y-axis. Domain is how it covers your x-axis. And here, left to right is your x-axis. And this is going to continue spreading wider and wider as it goes up. So it's going to be all real numbers. Most of the time, with a parabola, your domain will always be all real numbers. Alright, the next thing we're going to talk about is comparing the widths of parabolas. The coefficient of the x squared term in a quadratic function affects the width of a parabola as well as the direction in which it opens. So we talked about the number in front of x squared tells us if it opens up or down. Now we know that it also tells us how wide the parabola is. So when the absolute value of n is less than the absolute value of n, the graph of y equals mx squared is wider than the graph of y equals nx squared. So what that tells you is the smaller the absolute value of the leading coefficient, the wider the graph. Okay? All right, here we have negative 4x squared, 1/4 x squared, and x squared. The absolute value here is 4. Absolute value here is 1/4. The absolute value here, this is an understood 1. All right, so the larger the absolute value, the wider the graph. The smaller the graph. The larger the absolute value, the smaller the graph. So this is our larger absolute value. It's going to be our most narrow or our narrowest graph. This is our smallest absolute value. It's going to be our widest graph. So it's the opposite. The bigger number has the tighter graph. The smaller number has the wider graph. And then x squared is just going to be your normal. Alright, so once again, you're going to need to pause and make sure you get these notes copied down on the widths of parabolas. Alright, the y-axis is the axis of symmetry for graphs of functions of the form y equals ax squared plus c. the value of C translates the graph up or down. So we're going to graph these two. All right, so when it doesn't have a B, a term in the middle, it doesn't have just an X term, then the y-axis is the axis of symmetry. All right, so when I'm graphing just y equals x squared, I'm going to use -2, -1, 0, 1, and 2. So I'm going to have -2 squared, which is 4, -1 squared, which is 1, 0 squared, which is 0, 1 squared, which is 1, 2 squared, which is 4. Okay? Then I'm going to have -2 squared minus 3. -2 squared is 4. 4 minus 3 is 1. -1 squared minus 3. 1 minus 3 is -2. 0 squared minus 3. 0 minus 3 is -3. 1 squared minus 3. 1 minus 3 is -2. And 2 squared minus 3 is 4 minus 3, which is 1. So first I'm going to graph y equals x squared. Alright, so I'm going to make a coordinate grid here. And I know both of these are positive. They're going to both open upward. Okay, so I'm going to have -2, positive 4. 4, -1, positive 1, 0, 0, 1, 1, and 2, 4. Alright, so this is my first parabola. Now this second one, C is -3. This is my C value. C translates the graph up or down, so this tells me that it's going to go down 3. So that means I should be able to just move every point down 3. So this one should go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Now let's double check. My first one should have been at -2, 1. So this is -2, 1, -1, -2, 0, -3, 1, -2, and 2, 1. Alright, so all of that worked. So this is my second parabola. Okay. Alright, so now that proves to us that C told me to translate this graph 3 units down. So it was the same graph as this one, it just moved 3 units down. So see, those look the same, it just moved 3 units down. Alright, make sure you rewatch the video, stop, pause, rewind. Make sure you understand how to do these examples before you start trying to do the homework.